Hey everybody. Today I'd like to look at the area of a circle, but first we're going to look at a couple basics. So I'm going to draw a circle. Let's assume that it's a perfect circle, and I'm going to draw a point. This point is the exact center of that circle. Now I'm going to draw a few lines of interest. First line being drawn from that center to any outer edge, and this can be at any point of the circle. I just chose a random angle. This length of the line is calculated as the radius. We then can draw another line, and it's going to be from one side of the circle to the other with it crossing through the center. Oh, assume that went through the center. That is called the diameter. And we know that the diameter, if we were to put like a radius on one side and a radius on the other side, is equal to 2 times the radius. Another length of interest is the length, like let's say if I were to pick any point on the circle and walk all the way around to the other side, that would be the circumference. And the circumference is calculated by the diameter times pi. Now, what is pi? So pi is actually a constant. A lot of you may be familiar with it. It's approximately 3.14, but it goes on indefinitely. There's many ways to calculate this, which I'm not going to get into, but let's do like a very crude, rough physical representation. Let's say we have a floor, and I get a perfect circle. And this perfect circle has a radius of 1. Let's say I take the point of this circle, and then I roll it. So I'm going to roll it in this direction. And of course, it's going to, that point is going to come up, it's going to get to the top, it's going to keep rolling, and then it's going to get to the bottom. So if I were to mark that with a piece of tape, for example, I could track it that way. And then if I were to take a measuring tape and measure from that point to this point on the floor, I would get that this is approximately 2 times pi. So if I were to calculate it, it would be about 6.28. And let's say that the radius was, a centimeter, then this would be 6.28 centimeters. You could do that in inches, right? If it's 1 inch, it would be 6.28 inches, and so on. Now, of course, this is rough, but this is an approximation. So the reason it's 6.28 is because the circumference is equal to d pi, and we know that d is 2r pi, and if r is 1, that's just 2 pi, and 2 pi is approximately 6.28. All right, now another thing I'd like to look at on a circle, of course, is the area. So what is the area of a circle? Of course, this is the full dimension of the inside of the circle. If you've memorized the equation, if you're familiar with it, you might know it as pi r squared. But how did we get this equation, and why is this the equation for the area? Let's take a quick look at a visual representation. So I'm going to draw another circle, and I'm going to slice it up into pi slices. And let's do 8. So assume that all of these pi slices are exactly equal in area. They're all identical. And I'm going to look at one of them for now. I'm going to take that pi slice out and draw it. It's going to be a very crude drawing, but assume it's perfect. So I'm going to draw that one. Now let's say, I draw the next one. And I just keep going for all of the pi slices. So this is 7, but now what I'm going to do is I'm going to draw a half pi slice on either side. So this is going to be a half, and this is a half. So that's 8 total pi slices, which represents the 8 pi slices in the circle. Now this looks a little more like a shape that we're familiar with, right? A rectangle. And we know that the area of a rectangle is equal to the width times the length. Now what is the width? Let's say the width is this, And if we were to look at this half pi slice, we can kind of see that the width is approximately this length here, which would be looking at the circle that length. And of course, that's from the center to the edge, which is r. So we can say that this rectangle's width is approximately r. And we're saying approximately here because we have these curve pieces going out. So it's not a perfect rectangle, obviously, but it's an approximation for now. And then if we look at the width, or the length, sorry, we can kind of count these pi slices. So we have 1, 2, 3, 4. So if we were to count these here, right, so this is a full arc here. So this is 1 arc, 2, 3, 4 arcs. Now that is half the circumference. So the length is equal to c over 2. Again, this is an approximation because the actual length here is not quite the circumference because it's curved. So we're saying that it's approximately, it should be approximately c over 2. Now let's say that we cut these pi slices really thin, very, very, very thin. Now, of course, the thinner you make it, the closer that this arc looks like a straight line. So if we were to make these pi slices very, very thin, this would actually look more and more like a perfect rectangle. And in that case, you can actually say that if the pi slices goes to infinity, this is an accurate representation of the area. So let's plug these in. So let's say area equals width times length, which we know is r times c over 2. Now c, the circumference, we know is diameter times pi. So we have r d pi over 2. And then we know that d is 2r. So we can say r and then 2r pi over 2. So a equals, so let's cancel out these 2's. And then we have 2 r's, so that's r squared. So pi, right, pi times r squared. And that is how we can calculate the area of a circle, or derive. It's kind of hard to draw these pi slices going really thin and closer to infinity, but I've actually done up a little example on my website, physmatvisuals.com. So I'll provide a link in the description, and you guys can take a look at that and play with the slider and see how this shape gets closer and closer to a rectangle and how we can derive the equation for the area of a circle. If you have any other questions, just let me know in the comments, and I'll be active and make sure I respond. All right, have a great day. Talk to you guys later.